This is the fourth video to section 1.2. And in this video, we'll keep talking about sampling. We have two types of sampling in this case. One is with replacement, one is without replacement. At the top, when we have a member of the population that is selected, and that member is returned to the population and might be selected more than once, we call that sampling with replacement. But when a member of the population is selected and that member does not go back into the population, each member is only selected once then and has no chance of being selected again. We call that sampling without replacement. True random sampling is done with replacement. But with a large population, oftentimes it's done without replacement. Why do you think this is the case? Well, that's because with a very large population, if you remove one member, the total amount of the large population does not change that much. So if you have a population of, say, 1 million people, a very large population, and you select one member, the population is not changed very much at all by removing or replacing that one member. When the population is large, sampling without replacement is approximately the same as sampling with replacement. When analyzing data, there are two types of errors to be aware of. We have an error that happens when we're sampling, and we also have a non-sampling error. An error may occur elsewhere, but the sampling was actually done just fine. When gathering a sample, try to gather the largest sample that is representative of the population as possible. The larger the sample size, the smaller the sampling error. And in statistics, a sampling bias occurs when a sample is collected from a population, whereas some members of that population are not selected or not as likely to be selected. On the next page, we have a list of common problems that occur when sampling. Take a moment to pause the video and familiarize yourself with some of these common problems before we go to example 6. Now, in example 6, we talk about a poll that is given, and one of the questions asks, do you feel happy paying your taxes when members of the presidential administration are allowed to ignore their tax liabilities? Now, if we have 11 people that responded to this question, and we read that each one said no, do you see a potential problem here with samples? Perhaps these are self-selected samples, where only people who are interested in the topic are choosing to respond. We also have a sample size issue. 11 participants will not accurately represent the opinions of a nation. There is also undue influence here. The question is worded in a way to generate a specific response. We also have an issue that falls under a self-funded or self-interest studies, meaning this question was generated to support one person's claim, and it was designed to get the answer that the person desires. Moving on to the next page, we'll talk about variation in data and samples. Variation will often present itself in any set of data. It's only natural that as you measure or record data, your data may vary from data someone else is taking for the same purpose. Variation is to be expected, but we do have some possible ways to decrease the amount of variation. One important factor is increasing the sample size. That reduces the variation, and as mentioned earlier, it also reduces the sampling error. But how large of a sample is good enough? We'll go into this in great detail later, but right now we have a few tips. If the population is small, try to survey the entire population. Samples of a few hundred observations, or even smaller, are sufficient for many purposes. And 10 to 20% of the population size can be used as a rough estimate for a good sample size for larger populations. Moving down to example 7, letter A, is a sample size of 1,000 a reliable measure for a population of 5,000? And the answer is yes. 1,000 is 20% of the population. For letter B, is a sample of 500 volunteers a reliable measure for a population of 2,500? And in this case, although the 500 is a good number, the fact that people are volunteering is not good. So this sample consists of volunteers, making it a self-selected sample. That's not reliable. Moving down to example C, Paul and Diane both sample 100 students from their college using the same random sampling method. They estimated the average GPA of the students at the college. Paul's data results is a mean GPA of 2.9 and Diane's is 2.7. Is this difference something to be concerned about? And the answer is no. We expect there to be small variations in results, especially if Paul and Diane are sampling from the same college. And that is the end of the fourth video for section 1.2.